Welcome back. Today we're going to be talking about unit rates and tables. Our content objective is students will be able to compute unit rates and determine the constant of proportionality. Language objective students will be able to state which rate makes more sense. And why am I learning this? Well, it's important for many real world problems like computing your wage. So for background knowledge, just to remind ourselves, a unit rate is basically a rate that compares quantities with different units, and most specifically, it has a denominator that is a 1. So many of y per 1 of x. So a quick summary of a ratio is just remember that ratios do not have units. They're always written as fractions. They're never written as whole numbers or mixed numbers. And we typically reduce to simplify them. Now as for rates, in this case it's usually not specified. For unit rate it's very specific. We need to make sure that the denominator has to be a 1. Okay, and we always write the units. So again, with rates we don't necessarily have a specific denominator, but unit rate must have a denominator of 1. And we divide to simplify, unlike ratios. Now there is an exception. When we are working with fractions, we also do divide to simplify, but that is our main exception. And of course, money usually goes on top, aka the numerator of our fraction. So here in this example, in 1/10 of an hour, Jane can clean 5/8 of a window. What is her average rate per hour? So if I want to know how much it is per hour, what's her rate, I'm going to go ahead and put 5/8 of a window as my numerator. Let me just put window for short. Per 1/10 of an hour, because that's how much she's able to do in 1/10 of an hour. So in order to figure out this rate, aka unit rate, what I'm going to do is go ahead and divide. So this is going to be read as 5/8 divided by 1/10, which can be rewritten as 5/8 times the reciprocal, which is going to be 10 over 1. I'm going to check if I can cross reduce, which I can by a factor of 2. And that's going to leave me with 25/4. Now, it is going to be 25/4 windows per hour. But in a real life situation, that's not how you would answer it. You would want to turn that into a mixed number. Now with unit rates, we do turn them into mixed numbers. Now with ratios, keep in mind, you just leave it as a fraction. So I'm going to go ahead and do 25 divided by 4. This is going to go in 6 times with the remainder of 1. So we have 6 and 1/4. So here I would go ahead and say she's going to be able to do 6 and 1/4 of a window or windows per hour. Now, what is her average time per window? In order to determine her average time per window, what we're going to do is actually do the reverse of it. Because we want to know how much it is per window, we're actually going to set it up as hours over window. So in this case, we're going to do 1/10 of an hour over our 5/8 window. We're going to go ahead and simplify that as 1/10 divided by 5/8. Which is basically 1/10 times the reciprocal, which is 8 over 5. I can cross reduce by 2, which is going to leave me with 4/25. So this means she can do 4/25 of an hour for each window. That's how much it's going to take her. So 4/25 hour for every single window. So depending on how they ask the question is how you're going to set up your fraction in order to determine what that rate will be. Now you could have also turned it into a decimal, which is basically 16/100ths of an hour per window. So whichever way, same thing. So please remember that this very first piece of information is just a rate. However, by computing it per 1, we are technically finding the unit rate. So all of these are unit rates. Now taking a look at this example, it says it took Sally 5 hours to drive 220 miles. First, we're going to ask ourselves the question of which makes more sense. Should it be hours per mile or miles per hour? Hopefully your answer is miles per hour. In fact, you see it on the freeway, you see it in residential streets. They are posted speed limits, and you do see it as MPH, which does stand for miles per hour. Now, with that, we're going to look at the three different parts. We're going to look at the ratio, we're going to look at the rate, and we're going to look at the unit rate. So as a ratio, we would set it up as 220 over 5. Again, we're trying to set it up as miles per hour. Our rate would include the units, so we'd put 220 miles per 5 hours. Specifically for the unit rate, we're going to have to divide because we want to know how much it is for 1 hour, and that's going to be 44 miles per 1 hour. So something that you're going to find is ratios are not always simplified. Now, in the previous lesson, we did simplify them. However, it's not always a requirement. For rates, again, it's not simplified necessarily, but for unit rate, it must be simplified. So since Sally travels 44 miles for every hour, we can fill out a table. We have enough information to figure out some other things. So in 1 hour, of course, she would go ahead and go 44 miles. But in 2 hours, she would do double that, and that would mean she'd go 88 miles. So again, how did I get 88? I just doubled it by simply multiplying it by 2. So the unit rate was 44, and I multiplied it by 2. Now for 3 hours, if she's going for 3 hours, that means she's going 44 for the first hour, 44 for the second, and 44 for the third. So a quick way of doing that is simply taking 44 and multiplying it by 3, which would give me 132 miles. So 44 miles per hour is the unit rate. And guess what? Just the number alone, 44, is what we call the constant of proportionality. So the constant of proportionality can be thought of the constant multiplier. Why? Because you'll notice to figure out this entire table, we constantly multiplied by 44. So hence the name constant multiplier. So here, let me show you, 1 times 44 is 44, 2 times 44 is 88, and 3 times 44 is 132. So for number 2, it says it took Derek 7.5 hours to drive 220 miles. So which makes more sense, hours per mile or miles per hour? Well, we kind of already answered this in the previous one, so again, hopefully you still say miles per hour. So let's look at the ratio, the rate, and the unit rate. For the ratio, we would set it up as miles over hours, so it's going to be 220 over 7.5. The rate is going to be very similar to the ratio, except it's going to have units. So it's going to be 220 miles per 7.5 hours. But for the unit rate, it's very specific. We want to know how much it is for 1 hour, and for that reason, to simplify, we will divide. So 220 divided by 7.5 is going to come out to be 29 1/3 miles per hour. So again, ratios are not necessarily simplified, rates are not necessarily simplified, but unit rates must be simplified, and we do that by dividing. So since Derek travels 29 1/3 miles for every hour, we have enough information to fill out a table. The unit rate gives us a lot of information. So I can go ahead and say, well, 1 hour, it's going to take 29 1/3. In 1 hour, you're going to go 29 1/3 miles. So in 3 hours, how far is that going to take you? Well, in 3 hours, that's 3 times as long, so that's going to take 3 times as far. So for that, I'm just going to simply multiply by 3, and it's going to give me 88. Now, just a quick tip if you forgot, what you're going to want to do before you multiply is turn this into an improper fraction. So you just simply do 3 times 29 plus 1, turn it into an improper fraction, and then turn this into a fraction as well, and then multiply it from there. It's just a quick tip if you forgot. So since it's going to be 88, that means in 3 hours, Derek is going to go 88 miles. So what is our constant multiplier? It's going to be our 29 1/3, which can also again be referred to as the constant of proportionality. That is the more formal definition. So as proof, let me show you 1 times 29 1/3 is what gave me the 29 1/3. 3 times 29 1/3 is what gave me the 88. So now for number 3, it says, in 3/5 of a day, you paint 4 2/3 rooms. So what makes more sense? Days per room or room per day? Okay, I'm going to go with rooms per day. And why? Typically, time goes in the denominator. Now, I'm not going to say this always happens, but you think of it in terms of time, per minute, per hour, in this case, per day. So, for that case, let's go ahead and set it up as the ratio, the rate, and the unit rate. The ratio is going to be rooms per day, so we're going to go ahead and do 4 2/3 over 3/5. For the rate, we're just going to include the units, so 4 2/3 over 3/5 days. And for the unit rate, we're actually going to have to simplify this. So I'm going to go ahead and work it out for you. So here we're going to do 3 times 4, which is 12, plus 2 is 14. So I'm going to go ahead and change that to 14/3. This does mean division, so I'm going to divide by 3/5. Now from here, I'm going to go ahead and turn it into a multiplication problem. So it's going to be the reciprocal, which is 5/3. I'm going to check if I can cross cancel. I cannot. So I'm going to be left with 70 over 9. Now, in terms of a unit rate, it is helpful to turn it into a mixed number because I want to know how many rooms could be done in a day. So here we're going to change that into a mixed number. This is going to go, let's say, 7 times. So 7 7/9. So here I'm going to say this person's going to be able to do 7 7/9 rooms per day. So since this did ask for how much could be done in one day, I can go ahead and fill out that it's going to be 7 7/9 rooms. Okay, so let me clean that up for you. Now they're asking me for more information. So they're saying, okay, well, in one day, there could 7 7/9 room will be completed, but what if what about 10 days? That's 10 times as long. So if it's 10 times as long, then that means you're going to do 10 times as many rooms. So in order to figure that out, I'm going to go ahead and use the constant of proportionality, aka the constant multiplier, and do 10 times 7 7/9. Which is going to give me 77 7/9. Now again, if you need help with doing the actual arithmetic of it all, I would definitely convert this into a mixed improper fraction and turn 10 into a fraction. So 10 over 1 times 9 times 7 is 63 plus 7 is 70, so it's going to be 70 over 9. And you can just go ahead and go from there, and this is what's going to turn it into 77 7/9. Now, with the same idea here, since it's going to be 1 1/5, it's going to be 1 1/5 times more. So simply multiply that by 7 7/9, and you'd end up with 9 1/3. So the reasons why we're turning this into mixed numbers, because it makes more sense to say 9 1/3 rooms. Now, if we left this as an improper fraction, this would be 28/3 room, which doesn't give a person a good sense of how many rooms are being completed. Well, guess what? That concludes the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.